Speed. We know it as a rate of movement of an object. That is the distance covered by an object in a given time. So we need to measure the distance and to measure the time required to cover this distance. Although it appears quite easy, but in real life this may become a very different issue. In actual life, we have to deal numerous situations in which the distance covered by an object is so small that sometimes it can be overlooked, like the movement of a glacier, which is about few meters per year. Or sometimes the distance covered is so huge that it can travel many a times around Earth in just 1 second. And especially there is nothing which is traveling actually. That is an electromagnetic wave or light. Light is nothing but an energy which is moving at a huge speed of 3 into 10 to the power 8 meter per second approximately. So huge that a clock cannot be used to measure it. Also, this speed is something basic constant of nature, that multiplying the square of it with mass gives a tremendous amount of energy which we can find on a nuclear reactor. Sometimes we try to increase the speed so that we can achieve this from this. Also, moving something in the speed of light can expose some real mystery of the universe, like unknown particles, unknown forces, and understanding of speed can explain some basic questions related to universe, like the formation and expansion of universe. So today we are going to find real physics behind this word.
Hello everyone. So today we are going to find everything about speed and velocity. That is, what is these quantities actually are. Now from some days I have been googling around internet to find out about these quantities. And guess what I have found? I have found their mathematical definition and physical explanation just justifying that mathematical definition. Now that doesn't solve our purpose. That doesn't answer the question why and how the concept of speed and velocity has been arrived. And understanding this question is very essential because later onward we will find that some mathematical branches, especially calculus, completely depend upon the concept of calculus, completely depend upon answering this question. Because speed is nothing but finding the velocity if we know the displacement, and integral calculus is nothing but finding the displacement if we know the speed or velocity. So in this video, not only we are going to find what is speed and velocity, but also we are going to answer these two questions, that is why and how the concept of speed and velocity has been arrived. So here we have to find about speed and velocity. Now mathematically we can define speed as the ratio of distance covered divided by time required to cover that distance. That means if a car is traveling a distance d in time t, then its speed will be s is equal to distance covered divided by time. Now our question is how this d by t. Now we can easily find that this d by t is nothing but an unitary method. Suppose the car is actually taking a time t, so time t second is required to cover a distance of d. So in 1 second the car will travel a distance of d by t, and we gave it a name, that is s. Now say if the car is traveling a distance of 60 km in 1 hour, then by using this formula we can find that speed of the car will be 60 km, that is the distance covered by the car,
and it is taking a time of 1 hour, so its speed will be 60 kmph. That means 60 kilometer per hour. Now by this method we are not quite sanguine about in which direction the car is actually traveling. That means if the car is starting its journey from this point, say from this point A, then in 1 hour the car can move in any of the given direction. So the car can travel in this direction or this direction, or any of the direction the car can travel in 1 hour. So if we want to know in which direction the car is actually traveling, we need a physical quantity which not only define in 1 hour what is the distance covered by the car, but the direction in which the car is actually traveling. And that we do by denoting a physical quantity known as velocity. So velocity, if we define velocity mathematically, then velocity is displacement divided by time required to cover that displacement. Obviously, this will be a vector quantity because displacement itself is a vector quantity. So velocity is nothing but vector measurement of time rate of covering distance, which actually denotes in which the car is moving. Now we can find that the speed and velocity both has same unit because distance covered and displacement has same unit. So in SI system or CJ system, we can define the unit of displacement, we can define the unit of speed and velocity as meter per second, or in CJ system it will be centimeter per second. Now see, during its motion, if the car is not changing its direction of motion, then speed and velocity has same meaning, because here we do not need to, because in that case we do not need to specify the direction in which the car is traveling, because it was traveling in the direction which it was previously traveling. Now we come to the point why we do this S is equal to d by t. That means why we follow this unitary method. What is the purpose of doing, what purpose it actually solves by doing d by t. Now see, we can define speed and velocity effectively in two ways. The first one is, first purpose of doing this is how fast the car is actually traveling. That means as soon as it left the point A and goes for its destination, how soon it will reach to its destination. That means, say for example, the car has to travel a distance of 120 kilometer. So it is traveling 120 kilometer and say 120 kilometer and say its speed is 60 kilometer per hour. Now our question is how fast it will reach to its destination, say for example the point B. So distance between A to B is 120 kilometer. Therefore, we can use this formula for solving this problem. We can use this formula, that is, we have S is equal to d by t. So we can find t is equal to d by s. Now here distance is 120 kilometer and s is 60 kilometer per hour. So obviously it will reach to its destination to the point D after 2 hours from starting its journey. And by measuring the velocity, we can easily say in which direction the car is actually traveling. Now, there are certain phenomena, especially in mathematics, which we cannot explain by using conventional mathematics or by conventional reasoning. Like all of we have heard the story of a tortoise and a rabbit. Let a simple situation where the rabbit runs 10 times faster than a tortoise. And if during the starting of the race, the tortoise is 100 meters ahead of the rabbit, then by the simple logic, we will say that the rabbit will never be able to catch the tortoise. Because when the rabbit cover 100 meters to reach where the tortoise was, the tortoise proceed 10 meters, having run 1/10 faster. Again, when the rabbit runs 10 meters, the tortoise again proceed 1 meter. Running another 1 meter, the tortoise again 10 centimeter ahead of the rabbit. So the rabbit will never be able to catch the tortoise. But the simple thing is, infinite number of steps doesn't mean infinite number of time. Similarly, consider a situation where a policeman caught a car for overspeeding. And the police says to the driver, you are going at a speed of 100 km per hour and that is overspeeding. So driver may reply, that is not possible because he is not traveling at all for 1 hour. So covering a distance of 100 km is not possible. But all of we know what the policeman wants to say. All he wants to say is that if the driver kept on going the same way as he was going, then in the next hour he would cover another 100 km. But then suppose the driver replied, his foot was on the brake and he was slowing down, so he will definitely not cover 100 km. Or say there is a wall at the end of the road, so the driver may reply, if I go another kilometer, say 2 km or 3 km, I will run into a wall. This same kind of problem we will encounter during measuring the speed of a freely falling body. Say we want to know the speed of a freely falling body just at 5 seconds. But we will see very soon velocity of a freely falling body changes continuously. Then what we are trying to define, obviously we will require its velocity at very small interval of time. Say that is unit time. That we have done for defining velocity by using unitary method. That means the police may reply, you are going at 27.8 meter per second, and that is overspeeding. And why 27.8 meter? Because we are using the same formula, that is distance covered divided by time. And distance covered is 100 kilometer. 100 kilometer, we have to convert this 100 kilometer into meter. So 100 into 1000 divided by time required to cover 100 kilometer, that is 3600 seconds. So it will be 27.77 and approximately 28 meter per second. Hence, sometimes we need to know how much distance an object is covering in a small interval of time. That is, we need to step down in the time, as in case of a freely falling object. And sometimes we need to know how much distance it is covering in a large interval of time. And that is why we need to know distance covered in a unit time, and that is called speed. So that we just multiplied that distance covered in a unit time, that is speed, with the amount of the time, whether it is small or large, and we get the distance covered by the object.
However, this conventional concept of defining speed and velocity is only applicable to the speed of the object is very low as compared to the speed of light. Because due to the relativistic effect, then light itself loses its density and behaves like a physical dynamic. So moving forward in future as well as past may be possible. So that is another topic. So how to measure the speed of light is a different thing, and we will find that in another episode. So stay tuned for this from Finland Institute of Physics. Thank you.